Dear student, in our last video we learned the two important things. One is resultant of a vector and the one is direction of resultant of vector. We got the expression for resultant of vector r is equal to square root of a square plus b square plus 2ab cos theta, where a and b are the two vectors, and that equation we got by using parallelogram law of vector addition. Correct? Our equation na we call it as a law of cosine. R is equal to square root of a square plus b square plus 2ab cos theta. Our equation anna we consider as law of cosine to get the expression for resultant of two vector using parallelogram law of vector addition. ಕಲ್ತಿದ್ದೇವೆ. ಅದರ ಜೊತೆನೆ I provide one more formula is called law of sines. In case of law of sine, we got r divided by sin theta is equal to a divided by sin alpha is equal to p divided by sin beta. That equation you got, called the law of sines. ಇದು ಎರಡನ್ನ ಕಲ್ತಿದ್ದೇವೆ. Along with that, in a last video, I provide the bit introduction part to the resolution of vector. I explain about orthogonal unit vector. Again, in case of orthogonal unit vector, I denoted three types of unit vector there. One is along x-axis we taken as I cap, and the one is along y-axis we taken as j cap, and the one is along z-axis we taken as k cap. Where I cap, j cap, k cap represent the orthogonal unit vector along x-axis, y-axis and z-axis. Unit vector is the one. ಕಲ್ತಾಗಿದೆ already. Unit vector ಅಂದರೆ vector whose magnitude is 1 and it having particular direction. ಅದರ magnitude 1 ಇರುತ್ತೆ, it having particular direction. And today we do the continuation of this is related to resolution of vector. Dear student, resolution of vector is nothing but splitting of vectors into its component. Splitting of vector into its component. Splitting of vector into its components we call it as resolution of vector. Here splitting is also called resolving. Splitting is also called resolving. It is also called resolving of vector into its component is also called splitting of vector into its component. Andre vector anna adara component agi divide ಮಾಡುವ system anna we call it as a resolution of vector. Vector anna adara components agi divide ಮಾಡಬೇಕು. That system we call it as a resolution of vector. That's why it is called splitting of vector into its component is also called resolving of vector into its component. Again, keep one point clear in your mind. If I consider vector A is lies in xy plane. Imagine ಮಾಡ್ಕೊಳ್ಳಿ, consider vector A is lies in xy plane. Dear student, I consider this one is a y coordinate or y axis. This one is the x coordinate or x axis, like this. It is a y axis and this one is the x axis. Somewhere here I consider a point P, and here this particular point is taken as O. Here I consider the tail of the vector, and here I denote the head part of the vector, like this. Here OP is the vector. That vector we consider as a vector. That vector we consider as a vector. Remember, this a vector makes an angle theta. Angle subtended by the vector A from the x-axis is equal to theta. Automatically, this vector A is lies in the xy plane. X-axis ಮತ್ತೆ y-axis middle ಅಲ್ಲಿ ಇದೆ with a particular angle theta. Automatically, this vector is resolved into how many component? Two component. One component along x-axis, another component along y-axis. This splits into how many component? Two component. ಒಂದು component x-axis ಕಡೆ ಇದ್ರೆ ಇನ್ನೊಂದು component y-axis ಕಡೆ ಇರುತ್ತೆ. If I complete this diagram, just imagine if I complete this diagram, I consider this particular point is Q. Again, I consider this particular point is R. Again, there are two components now. One component made by the vector A is OQ. OQ anna I denote it as AX vector. Is a component made by the vector A along x-axis. Similarly, component made by vector A along y-axis is taken as AY vector. It is nothing but OR. Remember, E distance anna I will take it as AX, and this distance I assume it as AY. Remember, AX and AY are the component made by the vector A along x-axis and y-axis. Here, vector A is a resultant of how many component? Two component. ಯಾವುದೆಲ್ಲ component ಕೇಳಿದ್ರೆ ಒಂದು x component, ಇನ್ನೊಂದು y component. X component is AX vector, y component is AY vector. And again, one more important thing, AX vector with its magnitude I will take it as AX. Magnitude of AX vector is taken as AX. Similarly, magnitude of AY vector is taken as AY. Here AX and AY are the magnitude of component of vector along x-axis, component of vector along y-axis. Again, our requirement, you have to find out the AX and AY. And dear student, here vector A is equal to AX vector along x-axis plus AY vector along y-axis. Keep this result in your mind. Here vector A is nothing but AX vector along x-axis, AY vector along y-axis. Here AX vector and AY vector are the component made by vector A along x-axis and y-axis. Our requirement here, you have to find out the AX and AY. AX ಮತ್ತೆ AY ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. To get the AX and AY, we have to think about right angle triangle. ಇದು right angle triangle, just imagine. ಇಲ್ಲಿ right angle triangle ಯಾವುದು ಕೇಳಿದ್ರೆ OQP. By using right angle triangle, next from triangle OQP, from right angle triangle OQP, I want to get the expression for AX, I want to get the expression for AY. I assume this one as equation number 1. And from right angle triangle OQP, first I will go for definition of sine theta. What is the meaning of sine theta, or what is the definition for sine theta? Sine theta is nothing but opposite side divided by hypotenuse. Here in case of OQP, which one is opposite side? PQ is the opposite side. I will take PQ is the opposite side divided by hypotenuse is nothing but OP. Hypotenuse is nothing but OP. And dear student, here PQ line and RO line, how they are? Parallel. ಇಲ್ಲಿ PQ ಮತ್ತೆ RO line ಯಾವ ತರ ಇದೆ? Parallel ಆಗಿದೆ. If I take RO is equal to AY vector, its magnitude is equal to AY. Automatically PQ is also equal to ಎಷ್ಟಾಗುತ್ತೆ? AY. PQ is also equal to AY. Automatically we can write this one as sine theta is equal to AY divided by OP, where OP is nothing but A vector. We already taken OP is the A vector lies in a XY plane. Here OP is equal to A vector. We get AY is equal to A sine theta is the expression I got. AY is equal to A sine theta expression I got. This one is the component of vector A. This one is the component of vector A along y-axis. Is a component made by vector A along y-axis, or in a simple way, it is a projection made by the vector A along y-axis. It is a projection made by vector A along y-axis. Here AY is equal to A sine theta equation I got. That equation I call it as equation number A. Similarly, you have to think about the definition of cos theta, cos function. Dear student, what is the definition of cos function? Cos function anta helidare adjacent side divided by hypotenuse. In a right angle triangle, adjacent side andre idagutte. hypotenuse ಅಂತ ಹೇಳಿದ್ರೆ OP ಆಯಿತು. Adjacent side is nothing but OQ divided by hypotenuse is OP. Here cos theta is nothing but OQ divided by OP. Dear student, here OP is the projection or component of vector A along which axis? X axis is a projection made by the vector A along X axis is OQ is equal to AX. Here you have to take cos theta is equal to AX divided by, once again similar, OP is nothing but A vector, that you have to take it as A. Here AX is equal to, we got A cos theta. AX is equal to A cos theta. I call this one as equation B. Dear student, AX is the projection of vector A along which axis? X axis, or in other words, it is a component of vector A along X axis. And by using this results, I can clearly say that vector A, from equation 1, we can say that vector A is equal to, here AX vector plus AY vector, that we can take it as it is AX vector plus AY vector, that we can write it like vector A is equal to magnitude of AX vector, and I want to indicate the direction for that. Along x-axis direction is I cap, unit vector. Unit vector, its magnitude is 1. ಇಲ್ಲಿಗೆ I cap ಅನ್ನು ಇದಕ್ಕೆ ನಾನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ವ್ಯಾಲ್ಯೂ ಚೇಂಜ್ ಆಗಲ್ಲ. But it provides a direction along which axis? X-axis. Here I want to multiply I cap plus AY vector is a projection made by the vector A along y-axis. Y-axis ಗೆ unit vector ಏನಾಗಿರುತ್ತೆ? J cap ಆಗಿರುತ್ತೆ. J cap is a unit vector along y-axis. Automatically you have to take in place of AY vector as magnitude of AY vector. It become only a value. ಅದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಕೊಡಬೇಕು. Automatically I want to multiply unit vector is nothing but J cap. J cap is a unit vector along which axis? Y axis. Again, after simplification we can write vector A is equal to magnitude of vector AX is taken as AX itself. It taken as AX itself into I cap. I cap provides the direction. ಇಲ್ಲಿ AX ಅನ್ನೋದು ಬರೀ magnitude is a magnitude of component of vector A along X axis. I cap ಅನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೇನೆ. What is the value for I cap? 1. Is it provided direction? Yes. ಯಾವ axis ಗೆ? X axis ಗೆ. Next, magnitude of AY vector, we can write it like AY. Here AY vector na magnitude ಅನ್ನು we can take it as AY. It having only value. It is along which axis? Y axis. What should be a direction? Y axis direction. Automatically you have to take J cap. And again from equation A and equation B, vector A is equal to, here in place of AX from equation B, what I should take? A cos theta into I cap, it provided direction, plus equation A, AY is equal to A sin theta, it becomes A sin theta into J cap. Remember, this is the expression I got. Keep this point in your mind. Vector A is resolved into how many component if it is lie in XY plane? 2 component. What are the 2 component? A cos theta and A sin theta. You remember A cos theta is a component made by vector A along x-axis. A sin theta is a component made by vector A along y-axis. I got the vector A is equal to A cos theta into I cap plus A sin theta into J cap. If I want to find out the magnitude of that vector, magnitude of vector A is modulus of vector A is equal to, here I cap square, if I take its value is equal to 1 unit vector. I already told in the first video itself, magnitude is nothing but square root of this component, it is nothing but AX square plus AY square, component of 2 vector or component of this vector ax and ay. Here I consider by using this equation the component ax is a cos theta, ay is equal to a sin theta. I substituted here. Again after simplification I got magnitude of vector a, that itself is a, is equal to square root of, here ax square you have to take it like a square cos square theta, a square cos square theta, ay square is nothing but a square sin square theta. Dear student, here magnitude of vector a is nothing but a is equal to square root of a square, inside a bracket is cos square theta plus sin square theta, sin square theta. Dear student, you already learn cos square theta plus sin square theta is equal to 1. Automatically magnitude of vector a is equal to square root of a square. It provide answer a itself. It provide answer a itself. And dear student, this is one of the important thing related to resolution of vector. Again we can think about 3 dimension also. In a 3 dimension you have to think about rectangular components. By using rectangular component you have to think about 3 dimension by using different angle. Dear student, continuation of this. In case of resolution of vector, first I explain about 2 dimension is nothing but vector a is lie in between x and y plane. ಒಂದು ವೇಳೆ x ಮತ್ತೆ y plane ನಡುವೆ vector a ಇದ್ರೆ what should be the resolution of vector that we learn. Same kind if I consider 3 dimension. And again in case of 3 dimension you have to think about 3 rectangular components. That 3 rectangular components is also called a rectangular unit vector. We say that unit components. We say that I cap, j cap and k cap. Here I, j, k cap are called orthogonal unit vector. Its value is equal to 1. It provides a particular direction. Along x-axis the unit vector is taken as I cap, is a rectangular component along which axis? X-axis. And again j cap is a unit vector along y-axis, k cap is a unit vector along z-axis. Here I cap, j cap and k cap are mutually perpendicular. In our last class I already said, if I take this one is x-axis, y-axis, z-axis. Here I cap, j cap, k cap. All these 3 are mutually perpendicular. 3 mutual perpendicular ಆಗಿದೆ. And again ಇಲ್ಲಿ I consider 3 dimensional diagram or x, y, z axis 3 dimensional diagram. In case of 3 dimensional diagram I consider one rectangle. In case of this I consider vector OP. By seeing this diagram we feel that vector A or OP in between x and y axis. It's not so. It's a 3 dimensional diagram. I already said you have to imagine. 3 ಡೈಮೆನ್ಷನ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಒಂದು ಬಾಕ್ಸನ್ನು ಇಮ್ಯಾಜಿನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಇಟ್ ಇಸ್ ಅ 3 ಡೈಮೆನ್ಷನ್. 3 ಡೈಮೆನ್ಷನಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಟು ಥಿಂಕ್ ಅಬೌಟ್ ವೆಕ್ಟರ್ ಒ ಪಿ. ವೆಕ್ಟರ್ ಒ ಪಿ ಇನ್ ಅ 3 ಡೈಮೆನ್ಷನ್. ಹಿಯರ್ ಒ ಪಿ ಈಸ್ ರಿಸಾಲ್ವ್ಡ್ ಇಂಟು ಹೌ ಮೆನಿ ಕಾಂಪೊನೆಂಟ್? 3 ಕಾಂಪೊನೆಂಟ್. 2 dimensional is resolved into how many component? 2 component along x axis, along y axis. Other 3 dimensionally all the 3 axes are involved, automatically is resolved into how many component? 3 component. ಯಾವುದೆಲ್ಲ 3 ಕಾಂಪೊನೆಂಟ್ ಕೇಳಿದರೆ x ಕಾಂಪೊನೆಂಟ್ ax, y ಕಾಂಪೊನೆಂಟ್ ay, z ಕಾಂಪೊನೆಂಟ್ az. And keep one point clearly in your mind, vector a makes an angle from the x-axis that we denote it as alpha. Alpha is the angle made by vector A from x-axis. And again vector A makes an angle from y-axis that we taken as beta. Beta is the angle made by vector A from y-axis. And from the z-axis vector A makes an angle that we denote it as gamma. Gamma is a vector angle made by the vector A from the z-axis. Here alpha, beta, gamma are the angle between A vector with x-axis, y-axis and z-axis. Remember, in a 3-dimension, vector A resolved into how many components? 3 components that I already said, ax, ay and az. And again, alpha, beta, gamma is the angle between. Alpha, beta, gamma is the angle between vector A and x, y and z axis. Vector A from the x-axis angle is alpha, vector A from y-axis angle is beta, vector A from z-axis angle is gamma. Here alpha, beta, gamma are the angle between vector A with particular x-axis, y-axis and z-axis. And this one is the 3 rectangular component diagram, or along x-axis unit vector is I cap, along y-axis unit vector is j cap, along z-axis unit vector is k cap. Here you have to find out the component along x-axis, component along y-axis, component along z-axis. Simple math. Again, component along x-axis is the projection made by vector A along x-axis. x-axis ಮೇಲೆ ವೆಕ್ಟರ್ ಎ ಎಷ್ಟು ಕಾಂಪೊನೆಂಟ್ ಇದೆ, ಎಷ್ಟು ಪ್ರೊಜೆಕ್ಷನ್ ಮಾಡಿದೆ, that we taken as a cos alpha. A cos alpha. A cos alpha is the component of vector A along x-axis. Similarly, component of vector A along y-axis, ay. Component of vector A along y-axis ay is equal to A cos beta. Beta is the angle made by vector A from y-axis. Here alpha is the angle made by vector A from x-axis. Component of vector A along x-axis is A cos alpha, y-axis is A cos beta, and the last one, component of vector A along z-axis we taken as AZ is equal to A cos gamma. Remember, gamma is the angle made by vector A from z-axis. Here I got a 3 component ax, ay and az. For a 3-dimension, vector A is equal to ax vector plus ay vector plus az vector. That is nothing but component of vector A along x-axis, component of vector A along y-axis, component of vector A along z-axis. That becomes vector A is equal to, in place of vector Ax, I will take it magnitude of Ax vector, again I get only value. Then you have to take it as direction for that. What is the direction? Along x-axis I cap, unit vector, its value is equal to 1. Multiply madidare answer enu change agalla, but it provide a direction along x-axis. Next, magnitude of vector ay along y-axis j cap. Next, magnitude of vector A along z-axis az, and direction is k cap along z-axis. This one we can write it like vector A is equal to magnitude of vector Ax, we can write it like Ax itself, only value, it is a number, component, into I cap along which axis? X-axis, component of vector A along x-axis, plus this becomes ay into j cap, this becomes az into k cap. It is a formula I got, remember, where ax, ay, az are the particular value along x-axis, y-axis and z-axis. Remember, we can take an example like vector A is equal to 2i cap plus 3j cap plus 4k cap. ಕೊಟ್ಟಿರ್ತಾರೆ ax value is equal to 2, ay value is equal to 3, az value is equal to 4. ಡಯಾಗ್ರಾಮ್ ಬರಿಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, x y z axis. Along x axis component of vector A is, ಇದು 0 ತಗೊಂಡ್ರೆ 1 2 ಇಲ್ಲಿದೆ. Along y axis component is 3, 1 2 3 ಇಲ್ಲಿದೆ. Along z axis component is 4, 1 2 3 4 ಇಲ್ಲಿದೆ. You will get the comp vector somewhere here. ಇಲ್ಲೆಲ್ಲೋ ಇದೆ. It is ai cap, 3j cap, 4k cap. 3 dimension diagram imagine ಮಾಡ್ಕೊಳ್ಳಿ. ಇದು ಕಂಡೀಷನ್. And ಇದರ magnitude I want to find out. Next important thing, magnitude of vector A becomes square root of component along x-axis ax square, component along y-axis ay square, component along z-axis az square. It is a magnitude. Keep this result in your mind. And in case of continuation in a different events, automatically this one is also called a position vector. We denote this one as a position vector r. That position vector r is taken as x into I cap plus y into j cap plus z into k cap. Position vector r made a projection along x-axis is x, made a projection along y-axis is y, made a projection along z-axis is z. And by using this one is the representation of which vector? Position vector. It is a representation of position vector. It is a representation of position vector. And up to here we learn how we can resolve the vector into its component. Next continuation of that we discuss is nothing but analytical method. In case of addition of vector we discuss certain example, and after that we'll discuss the displacement, velocity and acceleration by considering vector concept that we discussed. At the end we're going to discuss the new concept called projectile motion. Thank you.